For the theoretical study, we'll talk about the differential equation of the charging of a capacitor. So here in this part, our aim is to study what will happen to UC with respect to time. But in order to find the solution UC with respect to time, we must find first the differential equation. Its solution, or the root of this differential equation, will be UC with respect to time. Is it constant? Is it increasing? Is it increasing as a line, as a curve, as sinusoidal? So our aim is to find UC with respect to time. But in order to find it, we must have first the differential equation. Now, how to write the differential equation of charging in terms of UC? We'll start with the law of addition of voltages in series, which will give us that U across the dry cell, which is E, equals to U across the resistor plus UC. This means E equal R times I plus UC. But we want to find in terms of UC. This means I must have another variable than I. So here we write, we know that I equal to dQ over dt, but Q and Q is equal to C times UC. So by substitution, we'll get dC times UC by dt, which will be equal to C duC by dt. And then now I can substitute here, then E equal RC duC by dt plus UC. And usually in differential equation, we divide by the part which is behind the derivative. So here we'll divide by RC, and we'll get duC by dt plus UC over RC is equal to E over RC. And that's it. This is the first order differential equation. In terms of UC, this means by finding the roots of this differential equation, we'll find UC with respect to the time. Now, in order to find the differential equation, I can also ask for the differential equation, but in terms of Q. So we'll start with the same part, which is law of addition. So here also we have E equal to UC plus UR, but I want it in terms of Q. We have UC equal to Q over C, and we have I equal to dQ over dt. So here E equal Q over C plus R times I, which is equal Q over C plus R dQ by dt. And then also we can divide by R here. So we'll get dQ by dt plus Q over RC equals to E over R. And this is the differential equation, the first order differential equation, but now it's in terms of Q. Now in terms of I, so here, in order to find in terms of I also, E equal UC plus UR. So E equal. Now, UC plus R times I. But I want to, in terms of I, so I don't need UC here, but we know that I equal to dQ by dt, which is equal to C duC by dt. This means I must have duC by dt. So what can we do? We can do the derivative or the equation. The derivative of E, which is constant, is 0. So it equals duC by dt. Derivative of I, so it will be R di by dt. Now this one, we can do a substitution by duC by dt equal to I over C. So it will become I over C plus R di by dt equal to 0. By dividing by R, we'll get di by dt plus I over RC is equals to 0. And this is the first order differential equation. Now, sometimes they can ask us to find UC in terms of I first. So if I want to find UC in terms of I, so how can we find it? We have duC by dt is equal to I over C. That's it here. So this means that duC equal I over C dt In order to find UC, I can do the antiderivative at both sides. So we'll have UC equal 1 over C I dt. And then I can find from here another time differential equation by only substituting here, in this equation. So we'll get E equal 1 over C antiderivative of I dt plus R times I. Now here we can't have an antiderivative in the differential equation, so I can derive both sides. So we'll have 0 equal I over C plus R di by dt. Pick conjugation at the same equation, so we can divide by R and get di by dt plus I over RC equal to 0. This is another way if they ask us to find UC in terms of I first. We still have the differential equation, but in terms of UR. Since I is changing, this means also UR is changing. So how does it changing? We have E equal UC plus UR. Same thing here. So I want UR, so I'll leave it, but I don't want UC. So we know that I is equal to C duc by dt. This means that duc by dt is equal to I over C. So I must do now a derivative here, and then we'll have 0 equal duc by dt plus dur by dt. But this is not done since here we have duc by dt. So this means I can put here I over C. So we'll have I over C is equals to I over C plus dur by dt is equal to 0. But I want it in terms of UR, so we can say here UR equal R times I, which means that I is equal to UR over R. So I can substitute and we'll get UR over RC plus dur by dt is equal to 0. And here we get the first order differential equation in terms of UR. This means that I have a solution in terms of UC, in terms of UR, in terms of I, and in terms of Q.